Hello, everyone. My name is Andy Sinclair. Today I'm going to talk about, is ChatGPT better than human review? I'm going to take a look to see if there's a potential solution for repossession companies and account updates. So I apologize that I wasn't in class in person yesterday. Unfortunately, when I was coming across the bridge, my car stopped. So that was unexpected and very frightening. But I made it over to Pennsville, and as you can see, I got a tow. So currently, my car is in the shop, but everybody's good. So I'm going to go ahead and move on. I do have a short introductory video, a 90-second video that'll talk about the repo space and what we're actually trying to accomplish here, as well as the steps and everything else that we went through. So the problem statement is that there's too many repossession updates unnecessarily require human review, which I'm trying to address by using ChatGPT's API, because who here has not even dabbled in ChatGPT quite yet, to distinguish between actionable and non-actionable updates. So what you see here on the right-hand side of the screen are different, they're actual updates, right? So you see here an agent, so what you see here is the top one, for example, is that an agent updated license plate from blank to MBL 4290. Now, do you think, as a group, as a collective, without knowing minimal information, that that is necessary for a human to come in and an outside, like a customer service person, to come in and identify, oh, hey, our team updated this license plate? The answer is no, it doesn't require it because the agent is us. So someone from the company already updated this update. So why do we need to have another update or an alert to say that this came through? Same thing here for notes on the case address. Hey, this address has been added to the case. Do we care about it? Well, as I'll show you in the next video, it doesn't because the software automatically updates the addresses throughout the account. And then you have this information that comes from a client, and it's only coming from one particular client, and it tells you where the actual level of the case is. So these levels indicate how long the customer has been past due. So 30 days, 60 days, 30 days would be a level 1, 60 days would be a 2, and then it's in 30-day increments and so on. So you see these different types of addresses of what's important, what's not important. Here we have an example of an approved for $150 flatbed fee upon contingent recovery and copy of receipt. So this is an example of an important update. And it's important because prior to that fee approval, that case was sitting in need info. So the team wasn't out looking for this car because we're all contingent. So once that fee was approved, then the team's able to go ahead out and start looking for those cars. Updates are merely a confirmation of failure. Because the repo industry is 100% contingent, meaning we only get paid if we pick up the car, right? It's only contingent based. So it doesn't matter if I write you a dissertation about a car. If we didn't pick it up, we didn't get paid and nobody cares, right? So updates are only a confirmation of failure. And for put it in perspective, IRS, the company's data that I used, based out of Philadelphia, they rip cars in Philly and Pittsburgh. In a month, they received between 5,000 to 6,000 assignments, which is anywhere between 1,500 to 1,800 repos, and that equates to 10,000 to 12,000 updates a month. So here I'm going to show you a quick video, and when you see the mapping software, that's ClearPlan. And that software, when you go ahead and you run an address like this, you'll click on that address, and then that's when you're going to go ahead and write in one of your love notes here.
At IRS, we use the latest technologies and common sense skip tracing processes to find and recover your assets faster. And efficient route planning is at the heart of all we do.
As you can tell, maybe I had a hand in creating this video.
From your recovery database network and
but there's ClearPlan.
With our route planning software. That means that our drivers have all the critical information right.
Maybe I had a really big hand in making these videos.
Names, addresses, vehicle descriptions, tag numbers, everything they need. When they head out to find your assets, the system automatically displays the most efficient route from address to address. They waste no time finding directions, choosing their next target, or planning alternate routes. The route planning information helps ensure that our drivers hit every address the first time, minimizing lost time from backtracking later. And advanced features in the software can even let drivers know the last time they visited each address. At IRS, the technology is complex, but the results are simple. Less wasted time and fewer days to repo. That's repo done right. Fast, safe, smart. Check out www.irsrepo.com to get more information about how IRS can get better recovery.
All right, awesome. So what you saw there was the route planning software. So the assignments coming into the system, and as the assignments come into the system, it would come up with that particular address that I was at. It was a Ford Mustang that was out for repo. So I ran that address. I drove to that address. I located the car. I VINed it. That's why I walked up. And then I went back to the system and I typed in a message saying, hey, I found this vehicle. Tow truck driver, come get it. And then I went off and I started driving to my next address. And that's when the tow truck driver came and picked up that car and then towed it away. So specific to this problem about these updates and why we want to try to classify these updates, FTEs are expensive, right? Because everyone wants to get paid. They want vacation. They want benefits, right? People are expensive. So at IRS, the average gross payroll for a customer service rep is about $50,000, and that's less FICA, those benefits that I talked about. All right, so we're talking about $50,000 for individuals to manage those updates. And currently, IRS has 14 CSRs, so that's around $700,000, again, without those fringe benefits. So we're talking about a lot of money, right? So what could we do if we took that number of 12,000 updates, 12,000 updates a month, or 144,000 updates a year, or 120,000 updates a year? What could we do to repurpose these individuals right within the team and find ways to make them revenue generators? So in the example, I really enjoyed this particular analogy here about the little boy who cried wolf too many times, right? Wolf, wolf, wolf. Everybody knows about this one. Boy cries wolf several times. He gets an audience to come out. There's no wolf. No one's there, right? He's like, okay, keeps calling. He keeps calling. People keep coming out. And then eventually people just don't believe him. But what actually happens, right? No one came to his rescue when he actually needed help, right? So the hypothesis in this example is that when there is no wolf, he cries for help, right? But we correctly rejected a false null, right? So that's negative. That's going to be negative or detrimental challenge, which was similar to our midterm, right, about those cancer screenings. So the same can be said for updates on a contingent model, right? Why are we keep asking for all of this information that's not actionable, that we can't use? And what's going to happen if we decide to eliminate all those updates and find the ones that we care most important about? So there's a whole culture change to doing this, not only just in terms of identifying it. So my plan to attack the problem was to access the data set through a SQL server, and then I needed to manually identify actionable versus non-actionable updates. And then I reached out to the client to say, hey, these are all the actionable and non-actionables. Do you all agree with this logic? So that way I can use it as my training set. I went and utilized ChatGPT. I'll quickly determine why that wasn't productive as I thought it was, an open box type of product. And then when I went to a BERT model, then what my results look like from a BERT model. So when I went and accessed the data through the SQL database, I needed to go ahead and start classifying all the updates as actionable and non-actionable. So when I did that, I was able to identify that there was 160,000 updates for the calendar year 2023. Non-urgent updates reached 145,000, and urgent updates, the one that we identified that required human intervention, was 14,000, right? So it becomes much more manageable at 14,000 updates than it did at 145,000. So what I went through is I went through all these updates that look just like this here on this table, and I manually went through and entered a 0 or a 1, right? 0 not urgent, 1 having an urgent, and then I went ahead and I had the client verify this information, right? So again, you'll see new address added, debtor is willing to surrender unit, right? So that's an update that comes to the system and says, hey, customer wants to give you their car back. Pick this up. Well, we got to make sure that we pick that one up, right? Otherwise, we're leaving money on the table. And then from here, it changed from pending approval to approved, right? So that flatbed fee that I mentioned earlier, that case was also approved, so we can go ahead and move forward with that process. So again, I reached out to the client, and the client identified that they had 14 support staff. They identified that this is a costly problem for them at $700,000 in payroll a year. And just having the ability to understand and interpret the actionable updates would be a significant value increase to their overall bottom line. And so what they requested were stats on the clients and which clients that they can start having deeper conversations with, saying, hey, you guys are really throttling us over here. What's going on? So this was the slide that I created for the client that identified all the clients and all of their updates. Right, so PK Willis, they came in pretty high with their urgent updates as well as non-urgent updates. And the reason for that is because that's their number one client in terms of volume. So it kind of aligns, it makes sense here. Ally, on the other hand, that's a direct client of theirs. So it's pretty interesting to see what the difference is, that they only had 700 urgent updates, whereas they threw in a lot of noise, right? Almost 10 times more the amount of noise than what we actually needed to see. But this was their information. This is what the client asked for after I showed them the exercise about all the urgents and non-urgents and how they wanted to understand and interpret that data. So what I did was I connected to ChatGPT, right? Because maybe one would think, or at least maybe I did, was, hey, let me just plug in this data into ChatGPT to the API and see what happens. See if it can identify urgent and non-urgent updates. So I connected to the 3.5 Turbo API, which was pennies upon pennies on the dollar, as opposed to the 4.0, which is more like a penny, an update, or a token rather. So all I didn't do any large training. I didn't do anything that similar to that. I just asked it to determine if the updates were urgent or not urgent, and then unknown. So the first 5 updates all read the same, right? And it was unplanned. And it said, your client has requested that this account be placed on hold for the following reason. On hold. We don't care because the case has been on hold. So since it's on hold, it's not in the field. Our humans don't need to take any interaction. So that's fine. So then what we did was I ran through this update and I gave it 4 runs to say, okay, let's just make sure that it hones in. So ideally, the result that I was looking for is that it would either be consistent between urgent, not urgent, or unknown. And as you can see, it was only able to do that twice, on a run 3 here, and then on a separate run here on run 1, where it thought it was not urgent and urgent. So because these results were all over the place, based upon the same exact logic, I was like, okay, it's not going to be an open, out-of-the-box product. I'm going to need to do much more training, and I didn't want to maybe invest the amount of money that it might have, or I guess should have taken, to get ChatGPT to solve the problem at hand. So I wanted to pivot and look at another model, so I went and took a look at BERT. But I knew that ChatGPT had the ability to do this. I would need to train it much more extensively than what I did. And to be fair, I gave it maybe 2 to 3 hours to give it a shot. And these were my results, right? So I would need to do a lot more working or a lot more training on it. And in that 1 month of December that I looked at, that cost me $1.75 for that 3.5. So then I went and moved on to the BERT, right? So I did a bidirectional encoder. And the advantages of the BERT model was that they're good with understanding ambiguous language. It's open sourced, which is what I plugged into through GitHub. And then it's easier for smaller, more defined language, right? So almost like our updates, right? How they're very short and sweet to the point. The disadvantage was time. The first BERT model that I had, I thought my computer was going to explode. It took over 14 hours. But then when I used my MacBook, right, I was able to run it in maybe an hour and a half. But that's because I got a Google Colab account, and when I used it on the V100, it took 90 minutes, right? So that was pretty awesome. And when I was able to, when the model finished, it took maybe 2 to 5 seconds to actually process every single one of the updates. So here, I have a quick video about the algorithm that was generated through the BERT model. So I was able to load the classifier model, and then the test text. This test text, excuse me, that's coming through would be the updates, right? And then here at the bottom, we'll identify whether the predicted class was correct or not, as urgent or not urgent. And we already discussed that flatbed fees are important, so it guessed correctly. Now, a normal update, right? So when you're running by the house and you say, hey, I ran by the house, the car's not here. We don't care, right? Because that's a confirmation of failure. Nobody cares about a single family home. Vehicle wasn't located. So what would BERT do with this in this particular model? It said, hey, we're not important. So perfect. Everything worked exactly as it should. Now, the BERT model in itself, when I went and used those results against that training data that I had talked about, that I had discussed, we saw that it correctly predicted that at the bottom right here, showed that the number of positives the model correctly predicted was 3,300. The true negatives, the top left cell here, was 36,000. And the false positives in the top right were 227, and the false negatives were 307. So all in all, it was still less than 5% in terms of the false negatives, which would be livable. However, we need to identify what that means on a fiscal standpoint, right? So we would need to assume that those are 307 assignments, not repos. And of those 307 assignments, what value would be lost there? Would it be those flatbed fees? Would it be those external service fees, or just getting the car out for repo? Maybe the customer wants to surrender the unit altogether. So the originality component that we had was comparing ChatGPT to BERT, other potential models, right? So Professor also shared with me a heuristic model, which would group, since most of the updates are very similar in context, right? A fee approval, volunteer to get the car, generically, right? We would be able to categorize them very easily, and that's what a heuristic model would be able to do. So comparing those, all those models and the efficiency about which one's better than the other, the amount of workload that's required or technical skills that would be required to stand up this product would be important, as well as utilizing these different models in auto repossession in and of itself. So what conclusions did I come up with is that the BERT model appeared to be best suited for this particular problem. ChatGPT takes a much more effort. Also need to be mindful of cost experimentation, because I'll need to go through a couple iterations to really hone in that skill. And then I need to figure out how to get the BERT model that I showed earlier, how to pickle it, the fun word that I learned in class earlier this month, and then find ways to embed it into our actual logic. And then finally, investigate the efficiency improvements for classification, because the closer we get to 100, obviously the more money that the customer would make. And we can also acknowledge that solutions do exist with further tuning. So my further research, what can I do? I can explore and compare the heuristic models. So compare all three models using a confusion matrix would probably be most effective. Find ways to improve the BERT model that I already have. Look for ways to implement it into the client workflow that I had just mentioned, right? Because they have varying cron processes that understand assignments as they come in. So we would need to find some type of cron job that would be able to put everything through that particular model, and then update the user experience alike. And then once we're able to do that, we could go ahead and take the BERT model here and find ways to go ahead and quantify it for savings. Right, so 150,000 mile or 150,000 updates. What does that actually come out to if we're able to dilute it to maybe 10% of that? So maybe 1,500 updates would be important. So those were the references that I utilized. The Boy Who Cried Wolf, they wrote a great article on it, and I felt like I could share with it. That's how I came up with that third or fourth slide. So being that I'm virtual, I'll host any questions. Luckily for me, there's no other questions. Thanks for your time, everybody.